In this video, we will be covering Chapter 1 of Stat 210. Chapter 1 covers sampling and data. But before we get started with Chapter 1, we want to talk about why statistics. Why are we studying statistics? Why do you have to study statistics? Why is it important in our world? Well, for those of you who are curious as to why you would want to study statistics and why statistics would be important to you, if you're interested in sports, criminal justice, education, politics, real estate, psychology, science, business, computer science, mathematics, medical field, then statistics is going to play a role in your interest or your future career path. Whether you are doing statistics yourself as you're doing research or you're just reading statistics, statistics will be something that you will be exposed to. And the purpose of Stat 210 is to kind of get you ready to know the basis of statistics, to be able to perform just the basic statistics for doing research, or to understand what statistics are saying as you're reading. You know, if you read a statistic, you want to know what that means, where it comes from. Whether it's just a descriptive statistic that has been calculated based on uh, data that's been gathered, or if it's an inferential statistic that's been calculated based on data that's guessing something about a population, you want to know what it's talking about and what implications it has. And that's what we hope to cover in Stat 210 this semester. This first chapter, we are going to have quite a bit of key terms. So in this chapter, we will learn key terms that are fundamental to probability and statistics. We will learn various sampling techniques for if you were going to design a study and go out and collect data yourself. We will learn how to design the experiments where you are collecting this data. And this chapter really gives us the foundation for conducting experiments and studies of our own, and just some key terms for being able to talk about statistics and probability, which is going to be important as we move forward. So our first key term of the semester is data. Now, data is just a set of observations. It can be numerical data, it can be descriptive data, where it's just qualitative words describing something. But data is just a set of observations with whatever you're studying. Now, probability is a number between 0 and 1 that is inclusive, so it can be equal to 0 or it can be equal to 1 or anything in between. And this gives the likelihood that a specific event will occur. Population is going to be all individuals, objects, or measurements whose properties are being studied. So it's not just the individuals, objects, or measurements that are having data collected from them, but it's all of them. So for example, we could be studying college students, but we're only collecting data from maybe Peru State College, Wayne State College, and Chadron State College. We're studying college students, but maybe our population that we're studying is all college students. So it's the data that you're collecting from where you're collecting your data from, it's just a subset of your population. Your population is all of the individuals, objects, or measurements whose properties are being studied. Parameter is going to be a number that is used to represent a population characteristic. Parameters are typically not very easy to determine because you would need all of the information from it. So when I say a characteristic, we're meaning some sort of statistic. So a number that's calculated from the data. So for example, a statistic or a parameter that you often would think of would be a mean. So a mean you'd think of as an average typically. So what is an average? An average is where you take all of the data values and you add them up and then you divide by the number of data values, right? So if we wanted to know the average for the entire population, we would have to sample the entire population. It's going to be pretty difficult to sample every single college student. Even if we just said all college students that are attending college in Nebraska, that's still pretty difficult. Even if we said that our population was Peru State College students, That's a pretty large population still to be able to collect data from every single one of them. So that's why parameters are a little bit difficult to calculate, and they can't be easily determined because the characteristics of it are are not going to be easy to gather the data for. Um, Now, instead of looking at parameters, oftentimes people will look at a sample and then collect a statistic. So a sample is a subset of the population that's studied. So if we're studying college students, as I said before, and then we wanted to collect data, we would maybe use a subset of the population, such as the Nebraska State College System, using students that are in the Nebraska State College System. So Peru State, Wayne State, Chadron State College students. That's what we're going to include in our sample. That is a subset of the population of all college students. Then if we wanted to find the average, we'd be finding a statistic. So this is a numerical characteristic of the sample. So we would be able to, maybe possibly find data from all of the Nebraska State College System students. And then we could find, add all of their values up, divide by the total number that we sampled, and we could find their mean or their average. And that would be a statistic. It's not the parameter because we're not talking about all college students, but it's a statistic because it's talking about the sample that we studied. Now, one thing to keep in mind when you're thinking about samples is you want to make sure that you have something called a representative sample. So a representative sample is a subset of the population that has the same characteristics as the population. So let's kind of switch gears here a little bit. Let's think about sports real quick. And basketball players. Basketball players typically have a fairly decent vertical jump. I mean, they're basketball players, so we always think, that they're jumping up to the basket. They have a fairly decent vertical jump, right? So what if I wanted to study college students and how high they could jump? And I'm feeling particularly lazy today. So instead of going and, getting data from maybe just all of Peru State College students, just wandering around campus, measuring people's vertical jumps, I'm just going to go down to the Al Wheeler Activity Center, and basketball is practicing. And I'm going to just, real quick, hey, basketball team, come over here. Let's get all of your guys' vertical jumps. I mean, they measure that regular anyway, so they could probably just tell me it. I wouldn't even have to do any measuring. Now, if I'm just gathering data from the basketball team, am I getting a representative sample of how well Peru State College students can do on a vertical jump? Well, most likely not, right? Each of you are Peru State College students. Do you think that you have the same vertical jump as basketball players? Do you think that your vertical jump's about average for a basketball player here? Probably not, right? Unless you are an athlete yourself, and then maybe it is. But think about it. Most of Peru State College's students are not athletes, or not athletes that try to have a good vertical jump. So if I wanted to have a representative sample, I would make sure that I sample students at Peru that aren't athletes, as well as some students that are athletes. Because if I completely left out all of the athletes when I was doing my study, I wouldn't be getting information about those students. And by leaving them out, I'm still not getting a representative sample. So when you're thinking about sampling and making sure that you're getting a representative sample, ask yourself, are there certain subsets of the population that have special characteristics in this area where maybe, like athletes would have a better vertical jump? So maybe I need to make sure that I include some athletes in my sample, but I also need to make sure that I include some non-athletes in my sample as well. So that's something to think about as you're thinking about sampling. And we're going to talk more about sampling in a little while. But now we know what a sample is. It's just a subset of the population that's being studied. A statistic is your numerical characteristic about the sample. And these can eventually, by the end of this semester, be used to say things about the population and the population parameter. And some things that I want you to notice now as we're trying to keep track of some key terms is population and parameter both start with a P and they go together. The parameter is talking about the population. And then notice that a statistic and a sample, they both start with an S, and the statistic is always talking about the sample. So P's go together, S's go together. And hopefully that'll help you remember which is talking about which. All right, let's talk about data just a little bit more. We're going to start with qualitative data. And I believe I've used this word already today, but qualitative data is data whose value is indicated by a label. So we're just describing something, we're using words, there's no numbers involved here. Now, in contrast, oftentimes when you think about statistics and doing studies, you're thinking numbers are involved, but that's just when you're studying quantitative data. So quantitative data is data whose value is indicated by a number. Now, each of these data types can be broke down a little bit more. With quantitative, there's a little bit more that we can do for breaking it down. There's discrete data. Discrete is quantitative data that is the result of counting. So these are going to result in whole numbers. There's going to be no decimals going on. You're thinking, you know, when this data was collected, did we count to get to this data value? In contrast, we have continuous. Continuous data is going to be the result of measuring. So there's a possibility of having decimals or having fractions, whereas discrete, there's no possibility of having decimals or fractions. So some examples of what discrete or continuous data could be with discrete data. Since you're thinking counting, you could think a number of text messages that you sent in a month. You would have to count to find that out, or you know, your cell phone company counts to find out how many text messages you've sent in a month. Versus continuous could be the amount of time that you've spent talking on the phone. You know, that's not going to be a whole number of minutes. You know, we can have a phone call that lasts a minute and 34 seconds. So continuous, there's going to be a chance of having a fraction or a decimal, whereas discrete is going to be the result of counting. So another thing that we could think of is, you know, if we were looking in backpacks, we could look in everyone's backpack and we could count the number of textbooks in their backpack. That would give us discrete data. Whereas we could also look and measure it by weighing the textbooks in a backpack. So counting the number of textbooks, that's discrete. Weighing the textbooks, there's a good chance we're going to get a decimal there on our weight. And so that would be a nice example of continuous. Now we can continue to talk about data and break it down by looking at the different levels of measurement. So with levels of measurement, 2 of these are going to fall in our qualitative data category, and 2 of them are going to fall into our quantitative data category. So first, there's nominal. Nominal data is data that cannot be ordered, nor can it be used in calculations. This is what we're thinking of with our qualitative data, and there's no specific order to it. So this could be what's a good example here? This could be different breeds of dogs. Very clear-cut categories, right? We can have one extra category for mutts, where we don't know what's been bred into them. But you know, there's clear-cut categories, and unless you're biased and you like a certain breed of dog, there is no order to which breed of dog is better. So this is data that cannot be ordered, nor can it be used in calculations. It's just putting things in categories. Now the next level of measurement is ordinal, and this is where you could order the data. So this is data that can be ordered, but the differences can't be measured. So you're not using it in calculations. We can't measure the differences, but it's data that can be ordered. So this is where we're thinking like class standing, where you're calling people freshmen, sophomore, juniors, seniors. There's a very clear-cut order to that, right? Freshmen are at the bottom of the totem pole. Seniors are at the top. You could think of it as, you know, titles within a workplace. You know, you have your basic entry level worker, you have your managers, you have, you know, maybe there's a lead manager, maybe there's a store manager, you know, and then it all goes all the way up to the very top where there's a CEO. There's labels, and there's a very clear order to those labels. So those are some nice examples of ordinal, where it's data that can be ordered, but the differences can't be measured. Next is interval. Interval is going to be our first example here in our levels of measurement of our quantitative data. So interval is data with a definite ordering, but there's no starting point, meaning there's no such thing as zero. There's no, like, zero doesn't mean nothing. The differences can be measured, but there's no such thing as a ratio. So when we think about interval, there's really just a very small set of things that can fall into the interval category. So here we're thinking of things like temperature, because 0 degrees Fahrenheit does not mean that there is no temperature. It means it's cold, right? So when you're thinking about temperature, and even if you're looking in Kelvin, because 0 degrees Kelvin is a true zero. But does that mean that there's no temperature? There's lack of temperature. Now there's still a temperature, right? So there's no starting point. It's kind of a relative measurement. So our differences can be measured, but ratios don't really make sense here. Another thing that you can think of here is any of your standardized tests, like your IQ test, ACT, SAT. Those are all going to be examples of interval. But for the most part, your numerical data, your quantitative data is going to be ratio. So ratio is data that has a definite starting point, that can be ordered, the differences and have meanings, and ratios can be calculated. So this is like where you're thinking like 0 means nothing. So if you're thinking about the time that it took to drive to school today, well, if you didn't drive to school today, it was 0 minutes or 0 seconds, which means it took no time because you didn't do it, right? So, anything like age and time and weight, basically all of your numerical measurements, except for those that we listed in interval, all of the rest of the numerical measurements are going to fall into ratio. So like the amount of money somebody makes in a year, the amount of miles that they walk, the number of text messages they send, the amount of time they spend on the phone, how many textbooks they have in their backpack. If there's 0 textbooks in there, that means there's no textbooks, right? So ratio is where 0 means nothing. There was nothing. So hopefully this kind of gives you an idea of how we're going to deal with our levels of measurement, what our different types of data are. And now we want to get into talking about how do we collect this data. We know what their levels of measurement are, but how are we going to collect the data? So there's a few different types of sampling, and there's one type that is, kind of the overarching best, but it's not always super easy to do or practical. But that best is the simple random sampling. So it's a straightforward method for selecting a random sample. You give each member of the population a number, then you use a random number generator to select a set of labels. These randomly selected labels identify the members of your sample. So like you could also think of this as like pulling a name out of a hat, using the like spinning name wheel they have online for like randomly selecting people, those sorts of things. That's what simple random sampling is. And this is the best because it gives you a truly random sample. Now, the next is stratified sample. And there's some reasons to want to try to do a stratified sample. So a stratified sample is a method for selecting a sample that's used to ensure that subgroups of the population are represented adequately. So you divide the population into groups, use simple random sampling to identify the number of individuals from each group to use. You're going to be, using that simple random sampling within each group. So this is where we're like thinking back to the vertical jump on campus and trying to make sure that we get a good sample. We could say, like we have different sports teams. We want to make sure we sample a few people from each sports team. And then maybe we want to sample, a few people from each of the clubs on campus. Or maybe we want to make sure that we sample a few students from each class. However we want to define those subgroups, and we can use pre-existing groups to define these subgroups. And then we're taking a few from each and every subgroup. And so stratified sampling can be really good at making sure that we do get a representative sample of our population. Now, the next type of sampling is often confused with stratified sampling. So with stratified sampling, we have subgroups, and then we use just a few from every single subgroup. With cluster sampling, we again have some subgroups. So this is a method for selecting a sample where you're dividing the population into groups. We use simple random sampling to select a set of groups, and every individual in the chosen groups are included in the sample. So here we have our subgroups, and we give each of them a number. We use simple random sampling, and we pick maybe 3 of them, and we use every individual in those 3 subgroups, and we don't use any of the other subgroups. So with stratified sampling, we get a little bit from each subgroup. With cluster sampling, we just take a couple of the groups in their entirety. With cluster sampling, you run into issues with having a good representative sample. So I would stray from cluster sampling if I was doing a study, if it was possible. Next is systematic sampling. Systematic sampling is a type of sampling that's used oftentimes like in factories when they're trying to do quality assurance testing and things like that. So this is a method for selecting a sample where you list the members of the population, use simple random sampling to select a starting point in the population, then you choose every kth individual in the list, starting with the one that was randomly selected. If necessary, you return to the beginning of the population list to complete your sample. So this would be like, oh, say we're at a factory, things are coming off of the assembly line, and we find a starting point using simple random sampling, and then we say we're going to sample every 5th item that comes off and just make sure that it functions properly. This would be systematic sampling. So we're choosing every kth individual to sample. Next is a convenience sample. Convenience sampling is the one method that I want you to avoid at all costs when it comes to collecting data. So convenience sampling is a method of selecting a sample, and this method selects individuals that are easily accessible and may result in biased data. So like think about doing a study on political views, and maybe you're collecting data on political views. Most of the time, and I say most of the time because it's not all the time, but most of the time, you and your friends have similar political views. Maybe not the same, but similar political views. And so if you were using convenience sampling and, it's convenient to talk to your friends and it's not convenient to, go out and get data from other people, then you're more likely to find people that all think the same way and possibly the same way as you, or most of them thinking the same way. And this could result in some biased data. So convenience sampling isn't the greatest, and it extends beyond politics. You want to make sure that you're trying to be truly random when you're collecting data, and the more random you are, the better. And we look at this and talk about this more later on in the semester when we start thinking about doing studies and doing hypothesis tests and predicting things about our population based on our sample, because we want to make sure that our sample is a really good representative sample of our population for us to be able to use that sample to predict something about the entire population. So long story short, avoid convenient sampling. Cluster sampling is not super great either, but the systematic sample and the stratified sample are pretty good, solid sampling techniques, as is obviously the simple random sampling. That is the best. That is the gold star of sampling. Now, one thing to keep in mind as you are doing sampling, there is such a thing as sampling with replacement and sampling without replacement. So sampling with replacement is once a member of the population is selected for inclusion in the sample, that member is returned to the population for selection for the next individual. Sometimes this is good, sometimes it's bad. There's cases where you don't want to for some reason select the same person more than once, and there's times where it's okay to select them more than once. And we kind of talk about this a little bit as we get into doing like our hypothesis testing and saying, should data be collected with replacement or maybe without replacement? So without replacement, a member of the population may be chosen for inclusion in a sample only once. If chosen, the member is not returned to the population for selection before the next selection. Um, so like a nice way of thinking of this is like, okay, we've got our hat with names in it, and I pull out a name and I read it. If I'm sampling with replacement, I'm going to put that name back in the hat and shake it up before I pull another name out. If I'm sampling without replacement, when I pull that name out of the hat, I'm going to read it, then I'm going to set it to the side. I'm not going to put it back in the hat before drawing another name. So hopefully we have a bit of an idea about sampling and how to collect data. We need to talk a little bit about experimental design and the different types of experiments and studies that you could be doing. So first off, before we start talking about experiments too much, we want to talk about observational studies, because you need to at least be able to observe before you can start doing an experimental study. So an observational study is where the researcher merely observes and does not control how the subjects are assigned to groups or which treatment a group receives. So an observational study, you're just watching. So like thinking about this, you're just sitting outside the dog park and you're observing how long each dog owner stays at the dog park with their dog. Um, Maybe you're making note of what type of dog it is, if it's a small, medium, or large dog, as you're timing to see how long each one's staying there at the dog park. But you're not doing anything to manipulate any of the subjects that you're studying. You're just watching. In an experimental study, you're doing something. You're doing something that has a way of manipulating the group. So the researcher assigns subjects to groups and has control over which treatment each group receives. So this, for instance, maybe you're doing a study about how long people stay at dog parks, and you're specifically interested in seeing how long they stay if a dog that's classified as an aggressive breed shows up. Now, we're not going to get into talking about aggressive breeds. There's some people who believe there's aggressive breeds, and there's some people that don't. Just say that we're doing this study, okay? So if we're doing this study about aggressive dog breeds, an experiment would be for a little while watching and seeing how long people stay at the dog park. And then maybe the next day, around the same time, you go to the dog park and you take a dog with you that's considered an aggressive breed. And you measure how long people stay at the dog park with a dog now. Is there a change? It's now become an experimental study instead of an observational study, because you're doing something that has control over your population. Well, not your population, your sample that you're looking at. So observational study, you're just watching. Experimental study, you have typically some sort of observational aspect, but then you also have some sort of treatment, something that you're doing to manipulate your population as you're studying them. We could also think of this, students taking a test. You could give students a basic skills test and just have all of them in the room and take the test. You're just watching. Or you could turn it into an experimental study where half of the room, you let them have music on, headphones in, whatever music they want, and the other half can't listen to music. Now you see how they do. You've done something to manipulate some of them. You said half of them, these guys over here on the right side of the room, you're all going to put your headphones on, you're going to listen to music. You on the left, you can't listen to music. You're seeing if music maybe has an impact as to how well they can do on a basic skills test. Now, this treatment that we've been talking about is the way that we're manipulating things. So it's different values or components of the explanatory variable that's applied to the experiment. So, our explanatory variable in the first one with the dog park was the aggressive dog breed. We were guessing that an aggressive dog breed showing up in the dog park maybe makes dogs stay less often. So your explanatory variable is that dog that's of the aggressive breed. Or in the second example that we talked about, this would be the music that you're letting students listen to. Now, there's also placebos. And placebos don't come into play with either of the examples that I've given so far. So let's talk about another one. Let's talk about maybe a weight loss drug. Maybe there's a study for a weight loss drug. With every study for a weight loss drug, there's something called a placebo that's involved. So this would be an experimental study. The research is assigning which groups each subjects are in, and there's some sort of placebo. So it's an inactive treatment that has no real effect on the explanatory variable. So some people in a weight loss trial are going to be given a pill that's identical in taste and color and smell to the actual weight loss pill that they're studying. The person that's taking it doesn't know if they have a placebo or the actual treatment. So there, and it's something that supposedly has no real effect on weight loss. So we're giving part of our group the treatment and part of the group the placebo, trying to see if, you know, the pill has anything to do with it, or maybe it's just a mental thing. If you think that you have something that you're taking that's working, it will work. And that's where, you know, the term placebo effect comes from, is because, you know, you think that you're getting the treatment, but you're not. Now, blinding is not telling participants which treatment they're receiving. And that's typically how studies are done. There's also such a thing as double blinding, and that's where the researcher that's interacting with people also does not know which treatment they're receiving. There's somebody else that knows which group each person's in, but the people that are interacting with them do not know. So that group that's receiving the inactive treatment, the placebo, that group is what we call the control group. So the group that we kind of compare to see if there's been a change. So, you know, we look at one, then we look at the other, we say, well, is there a difference? And later on this semester, we'll start talking about how we can study to see if there is a difference. So I believe that covers all of the key terms for this chapter. And this chapter really was just primarily key terms. But we have a few examples that I want to go through with you. And these examples should look quite similar to the homework. So this first example here, in a study, the data that you collect is temperature in Celsius. What level of measurement is this? I'll give you a moment to think, guess, write down your answer. So the correct answer here is interval. Remember, any sort of measurement of temperature is going to be interval data. Next, in a study, the data that you collect is color of shirts. What is the level of measurement? So thinking about color of shirts, it's qualitative data. So that was either nominal or ordinal, but there's no ordering which is the best color of shirt. And so this would be nominal data. In a study, the data that you collect is the ranking of artwork, poor, good, excellent. What is the level of measurement? There's an obvious order to this, poor being at the low end, excellent being at the high end. But this is just qualitative. This would be a good example of ordinal. In a study, the data you collect is age in years. What is the level of measurement? This is numerical data, so we know that's either interval or ratio. We ask ourselves, does 0 mean nothing? And it sure enough does. So that means that this would be ratio. In a study, the data you collect is number of traffic tickets. The data is, well, it's numerical, so that means it would be quantitative. In a study, the data you collect is color of backpacks. That means the data is Well, it's just a quality, it's a description about it. So this would be qualitative. Determine whether the value is a parameter or a statistic. 2/3 of the fish are orange. Is this talking about a sample or entire population? The way that it's worded, it kind of makes us think it's talking about an entire population. And typically when we have statistics given to us, we're going to see the word like in a sample. So for this one, this would be an excellent example of a parameter. 2/3 of the fish being the whole population, are orange. So our characteristic is 2/3. Population is the fish. Determine whether the value is a parameter or statistic. In a sample of students who pass statistics, 85% use statistics in their future careers. Well, we see the words in a sample. In a sample means that we are looking at a statistic. Is the value from a discrete or a continuous data set? The number of kittens a cat has in a litter. For this, we would have to count the number of kittens that there are in each litter. And counting means discrete, so this would be discrete. Is this value from a discrete or continuous data set? The average rainfall in July in inches. Well, this would be a measurement, so this would be continuous. A political scientist surveys 34 of the current 133 representatives in a state's Congress. What is the size of the sample? How many was actually sampled? 34 were sampled. Now, what's the size of the population? There's 133 representatives in the state's Congress. We're studying the state's Congress. The population size is 133. Does this describe an observational study or an experiment? A group of students are told to listen to music while taking a test, and their results are compared to a group not listening to music. This is an example I gave earlier. So the answer is A, experimental. Does this describe an observational study or an experiment? The temperature on randomly selected days throughout the year were measured. Well, there's nothing you can do to affect the temperature outside, so that would be an observational study. In a study, the sample is chosen by surveying every third driver coming through a toll booth. What is the sampling method? Well, sampling every third sounds like sampling every kth. And so this would be a nice example of systematic sampling. In a study, the sample of cats is chosen by dividing the population by hair length, short or long, and choosing 30 cats from each hair length. What is the sampling method? Since we're dividing cats by subpopulation, some subgroups, and then choosing some from each and every subgroup, that would be stratified sampling. In a study, the sample is chosen by pulling 50 names from a hat. What is the sampling method? Sampling method would be A, simple random. So we're just pulling things from a hat. In a study, a sample is chosen by asking people on the street, what is the sampling method? So you're just talking to whoever's convenient. So this would be convenience. In a study, the sample is chosen by selecting a room of the house and appraising all items in that room. What is the sampling method? We have a subgroup. We're just using one of the subgroups. This would be a cluster. So that is chapter 1. If you have questions, make sure that you are emailing your instructor. Otherwise, good luck on your homework, and we'll see you in chapter 2.